Welcome to Coding Wizards, your one-stop destination for mobile app developers. Today, we are going to conduct a mock interview session on advanced Android topics. Specifically, we're diving deep into the Android activity and fragment lifecycles. Think of this as a focused Q&A, really getting into the weeds, especially for developers who've been around the block a few times. Our goal here is to unpack these often tricky concepts, nail down the critical details, and really understand why getting this stuff right is just crucial for building solid, stable apps. Ready to jump in?
Absolutely. Yeah, this is fundamental stuff, and getting the nuances right can save a lot of headaches down the line. Let's do it.
Okay, great. Let's start with something foundational but often misunderstood. On save instance state and on restore instance state. What's the core difference? And maybe more importantly, when does the system actually call them?
Right, good place to start. So on save instance state, the system calls this on your activity or fragment, basically when it might get destroyed, but in a way that the user expects to come back to the same state. The classic example, green rotation. Or, if the keyboard pops up and forces a layout change, it's your chance as the developer to save tiny bits of UI state. Think like text in an edit box, maybe a checkbox state, scroll position, that sort of thing, into a bundle.
Okay, so it's for saving that lightweight UI stuff right before a potential configuration change wipes the current instance.
Exactly, before potential destruction. Now, on restore instance state, that's the flip side.
Yeah.
It only gets called after your activity or fragment has been recreated following that system-driven destruction. And crucially, only if you actually save something in the bundle earlier. You get that same bundle back, and this is where you pull the data out and reset your views to how they were.
So save before, restore after recreation. Simple enough. But what if the data isn't simple? What if you've got custom objects or like a list of things you fetched? On save instance state feels a bit limited for that, right?
Absolutely. You've hit a major limitation there, that bundle. It's really not meant for large amounts of data. Trying to cram big objects or complex data structures in there is, well, it's asking for trouble. You can easily run into the transaction below rug exception crash. Especially on older devices or under certain conditions. It's just not designed for heavy lifting.
Okay, so that's a definite don't. What should we use for more complex state preservation across, say, a screen rotation?
Well, there are a few approaches. One way, if you have custom objects, is to make them implement parcelable. That lets them be serialized efficiently, and then you can put them in the bundle. But you still have to be careful about the total size. But honestly, the much more common and robust solution these days, especially for data tied to the UI's lifecycle. That's the ViewModel.
ViewModels. Everyone talks about those. How do they help here specifically?
So the magic of ViewModels is that they are designed to survive configuration changes. When your activity rotates, it gets destroyed and recreated, right? But the ViewModel associated with it, it doesn't. It sticks around. The new activity instance just connects to that same existing ViewModel. So it's perfect for holding your UI data, your complex objects, whatever needs to persist across that short-term destruction and recreation cycle.
I see. So the ViewModel acts like a stable island for the data while the UI underneath gets rebuilt. What about data that needs to stick around even longer? Like if the user closes the app and comes back later, or the system kills the process?
Right, yeah. ViewModels don't survive process death or app closure. For that kind of persistence, you need proper storage solutions, something like a database. And for Android, Room is the standard recommendation. It's an abstraction layer over a SQLite, makes database interactions much easier, and it's designed for data that needs to persist long-term, totally independent of the activity lifecycle.
Okay, so ViewModel for surviving configuration changes, Room for true persistence. That really clarifies the different levels. Are there times then when you'd actively avoid using on-save instance state altogether?
Definitely. Like we said, if the data is too large or complex, use ViewModel or Room. But also think about this. If the state you could save in the bundle can be easily and very quickly recalculated or derived from the data you're already holding in your ViewModel, why bother saving it separately? Sometimes just letting the new activity instance pull fresh state from the ViewModel is simpler and cleaner than manually saving and restoring tiny bits of UI state in the bundle. It's a trade-off, but often avoids redundant work.
Makes sense. Don't save what you can easily recreate. Okay, let's shift gears slightly. You mentioned ViewModel being lifecycle aware, which brings us to Jetpack lifecycle components. What exactly is a lifecycle owner?
Sure. A lifecycle owner is basically just an interface, part of the Jetpack lifecycle library. Components like activities and fragments, they implement this interface. It essentially signals, hey, I have a life cycle that other things can observe. It lets the system or other components know about its current state, created, started, resumed, and so on.
And how does that connect to something like LiveData? Why is LiveData considered lifecycle aware?
Right, LiveData is probably the best example. It's an observable data holder. You put data in it, and things can watch or observe it for changes. The really cool part, the lifecycle aware part, is how it delivers those changes. When you observe live data from within a lifecycle owner, like your activity, the live data is smart. It only pushes updates to your observer when the lifecycle owner is in an active state. Typically, that means started or resumed.
So if my activity is paused or stopped, the live data just holds the update.
Exactly. It holds the latest value. But it won't call your observer's onChange method until the activity becomes active again. This automatically prevents a whole category of common bugs, like trying to update UI elements that aren't visible or aren't ready, which could lead to crashes. It ties the observation to the life cycle.
That's incredibly useful. Avoiding those crashes sounds great. So activities and fragments are lifecycle owners. Can we make our own custom classes react to the lifecycle in a similar way? How would we do that?
Oh yeah, definitely. You can absolutely create your own lifecycle aware components. The process is pretty straightforward. First, you create your class. Then you make it implement the lifecycle observer interface. It's just a marker. Tells the system this class cares about lifecycle events. Inside that class, you define methods for whatever lifecycle events you want to react to. You annotate these methods using an onLifecycle event and specify the event, like at onLifecycle event, lifecycle.event.onStart, or onStop, onDestroy, etc.
Okay, so you mark the methods for the events you care about. How do you connect this observer to the actual activity or fragment lifecycle?
Good question. In your activity or fragment, the lifecycle owner, you get its lifecycle object by calling getLifecycle. Then you just need one line, getLifecycle.addObserver. Once you've added it, the lifecycle library handles the rest. It'll automatically call your annotated methods in the observer at the right times as the activity goes through its states: onCreate, onStart, onPause, onStop, onDestroy. It lets you hook your custom logic right into the system's flow.
Wow, okay, so you can precisely tie setup and tear down logic to the lifecycle events. That seems really powerful for managing resources. Which leads nicely into my next question. How should we think about managing things like background tasks or network requests across these different lifecycle states to avoid, leaks and wasted work?
Right, resource management tied to lifecycle. This is absolutely critical. If you get this wrong, you get leaks, you drain battery, you crash. Each state gives you a hint. On create, that's for lightweight. One-time setup, nothing too heavy, on start. The UI is visible now, but maybe not interactive. This is often a good place to start loading data, maybe kick off background work that prepares things for the user. Network fetches, database reads perhaps, on resume. Now you're fully interactive. Handle user input, start animations, maybe refresh data that needs to be absolutely current, but be careful not to block the main thread here.
Okay, that covers the setup phases. Yeah. What about tearing down on stop, on destroy?
This is where the discipline really comes in. On pause is tricky. The activity is losing focus, maybe partially obscured, but it might come right back. So you should pause things like animations or video playback, maybe stop sensor updates. But don't release heavy resources yet. On stop. Okay, now the activity is not visible. This is the prime time to release the big stuff. Stop network requests you don't need running in the background. Release large memory allocations. Close database connections if they're tied only to this screen. If you don't do it here, you're likely leaking resources or wasting battery. And on destroy, this is the final call. If you didn't release something in on stop, you absolutely must do it here. Unregister broadcast receivers, close any remaining cursors, cancel any lingering asynchronous tasks, though ideally most cleanup happens in on stop if it's tied to visibility.
So the general rule seems to be acquire or start resources when needed, often on start or on resume, but be really diligent about releasing them when the UI is no longer visible on stop. Can you give some concrete examples of things developers often mess up here?
Sure. A classic one is manually managing network requests or background threads. You kick one off in on resume, user rotates the screen or navigates away, activity goes through on stop, maybe on destroy. If you didn't explicitly cancel that request or thread in on stop, it might keep running. Worse, it might hold a reference back to the destroyed activity context. Boom, memory leak. Modern libraries help, but the principle remains. Another one historically was database cursors. Forgetting to call cursor.close in onDestroy, or ideally earlier if done with it, was a common leak source. before Room helped manage this better. Broadcast receivers, too. If you register one in code, like an onCreate or onResume, you must unregister it, usually an onDestroy or onStop, depending on its scope, forgetting this is another leak.
And location updates, you mentioned those earlier.
Yes, location. Huge battery drain if managed poorly. You start requesting location updates, maybe in onResume, the user puts the app in the background. If you don't explicitly call remove location updates in on, pause, or on stop, your app keeps polling the GPS or network location providers, burning battery for no reason because the user can't even see the result. Always stop updates when the UI doesn't need them.
That makes total sense for battery life. Okay, moving into some more advanced territory. How do you approach designing an activity to handle more complex configuration changes, like split screen resizing or folding screens, not just simple rotation?
Yeah, handling dynamic resizing gracefully is important now. One way is to override on configuration changed. You have to declare in your manifest which config changes you handle yourself, like orientation, screen size, screen layout. If you do that, the system won't destroy and recreate your activity for those changes. Instead, it just called on configuration changed, passing in the new configuration. Inside that method, you'd manually adjust your layout, maybe swap fragments, reload resources for the new size or orientation.
That sounds like it could get complicated quickly, though.
It can, yeah. It puts the burden entirely on you. A more modern and often preferred approach is to design your layouts to be inherently responsive from the start. Use things like constraint layout with guidelines and percentages, flexbox layout, or dimension resources, diamonds.xml, tailored for different screen widths, smallest width qualifiers. If your layout is flexible enough, the system might be able to resize it correctly without you needing to intercept on configuration changed. The layout just adapts. But you absolutely have to test it rigorously. Test resizing in multi-window mode, test on different screen sizes, test rotation, test folding, if applicable. Responsive layouts only work if they're designed and tested well for those scenarios.
Testing, testing, testing. Got it. Okay, what about background services? They run independently. How do you manage interactions between a running service and an activity or fragment safely, given their different life cycles?
The service activity interaction, a classic potential minefield. The main danger is that the service can easily live longer than the activity that started it or wants to talk to it. If your service holds a direct reference to an activity instance, maybe a listener interface implemented by the activity, and then that activity gets destroyed, like rotation, but the service keeps running, you've got a major memory leak. The service is preventing the old activity from being garbage collected.
Ouch. So rule number one is probably service should never hold a direct reference to an activity or fragment.
Exactly. Never. You need decoupled communication. Use mechanisms like broadcast receivers. The service sends a broadcast. The activity registers to receive it, being careful to unregister, or use a messenger for RPC if the service is bound. You could also use shared data structures. Maybe the service updates data in room and the activity observes that data using LiveData. Or perhaps use a shared ViewModel scope to the activity if appropriate for the data type. Lifecycle-aware components like LiveData or Kotlin flow observed within the activity's lifecycle scope are also great for safely getting updates from a potentially longer-running background source.
Decoupling is key. Makes sense. What if you need a task to run for a long time reliably, even if the user leaves the app entirely, like downloading a large file or processing data?
Right, for tasks that need to outlive the UI and potentially the app process itself, you need dedicated background execution components. Two main options here. If the task needs to run somewhat continuously and the user needs to be aware, it's running think music, playback, active navigation, a file download with progress, you use a foreground service. It runs with higher priority and must show a persistent notification to the user.
Okay, foreground service for user-aware ongoing tasks. What's the other option?
For most other background work tasks that can be deferred, don't need immediate user interaction, and need guaranteed execution, even if the app is killed or the device restarts, the answer is Work Manager. It's part of Jetpack, super robust. You define your work, specify constraints like only run when on Wi-Fi or only when charging, and enqueue it. Work Manager handles all the complexity of ensuring it runs efficiently and reliably across different Android versions and device states. It's the go-to for almost all deferrable background tasks now.
Work Manager for the reliable, deferrable stuff.
Got it. And speaking of modern development, coroutines are everywhere. How does Lifecycle Scope help manage coroutines safely within the context of an activity or fragment lifecycle?
Lifecycle Scope is a fantastic addition for coroutine users. Basically, every lifecycle owner, activity, fragment, gets a lifecycle scope extension property from the KTX libraries. When you launch a coroutine using lifecyclescope.launch, that coroutine's lifetime is automatically bound to the lifecycle owner's lifecycle. The crucial benefit: when a lifecycle owner is destroyed, its own destroy, any coroutines launched in its lifecycle scope that are still running are automatically canceled.
Automatic cancellation. That sounds like it prevents a lot of potential leaks. It absolutely does. It stops coroutines from running in the background and potentially trying to access views or data from a destroyed activity or fragment. It's a huge safety net. Similarly, ViewModels have their own ViewModel scope, which cancels coroutines when the ViewModel is cleared. If you launch coroutines outside these scopes, you're back to manually managing their jobs and canceling them yourself at the appropriate lifecycle event.
Okay, that automatic cancellation is a major win. Let's pivot to troubleshooting now. Using all this lifecycle knowledge, how would you debug a really common problem? Data disappearing from a fragment after you rotate the screen.
Yes, the rotation data loss mystery. A rite of passage. First step is always confirm. Is the fragment actually being destroyed and recreated? Usually, yes, that's the default. If so, the data loss means state isn't being saved or restored correctly.
Yeah.
So you check on save instant state in the fragment. Are you actually putting the necessary data, the stuff that's disappearing, into the save instant state bundle? Then check where you're restoring it. Are you checking if save instant state is non-null in onCreate or on create view? Or are you using on restore instant state, and are you correctly pulling the data out and applying it back to your views or internal state?
So check the save and restore logic first. What if it's not simple view state, but more complex data that's vanishing?
That's often the real culprit. The developer assumed some data structure or fetch list would just magically survive, but it doesn't always explicitly handled. And this is where 9 times out of 10, the answer is move that data into a view model. If the data that disappears is the core data the fragment needs to display or work with, putting it in a view model solves the problem, because the view model does survive the rotation, holding on to the data for the new fragment instance to pick up.
View model to the rescue again for rotation issues. Okay, what about outright crashes that only seem to happen during a configuration change? How do you tackle those using lifecycle knowledge?
Crashes during config changes almost always point to a lifecycle mismanagement issue. You dive into the logs, the stack trace. Where exactly is it crashing? Is it an on-create right after rotation? Is it happening later, maybe on a resume? Is it an on-configuration changed if you overrode that? Often it's because something wasn't cleaned up properly from the old instance before it was destroyed, or the new instance is trying to access something that hasn't been initialized yet, or maybe it's trying to reinitialize something that wasn't fully torn down. So review your on-stop and on-destroy methods meticulously. Are resources really being released? Connections closed? Listeners unregistered? Background tasks canceled? An unreleased resource holding a reference to the dead activity is a prime suspect for causing instability or crashes during recreation. Tools like Leak Canary can be invaluable here for spotting those leaks during development. Also, double-check that any initialization logic in onCreate or onStart can safely handle being called again after recreation.
Leak Canary sounds essential there. Final problem, battery life. We touch on location, but more generally, how does smart lifecycle management help optimize battery usage, especially with things like location services?
It's fundamental. Battery optimization is largely about doing work only when necessary. Location is a perfect example. It's expensive.
Yeah.
So rule 1, only request updates when the user actively needs them, usually when your relevant UI component is in the resume state. Rule 2, and this is critical, stop requesting updates the moment the user doesn't need them, typically in on-pause or on-stop. Letting location services run while your app is in the background unnecessarily is just bad practice and kills a battery. Also consider the type of updates. Do you need high accuracy constantly, or would a lower accuracy or less frequent updates suffice? Can you use passive location or maybe geofencing instead of continuous tracking? And always check if location is even enabled, as provider enabled, before trying to request updates. It's all about minimizing that resource consumption by tying it tightly to the active lifecycle state where the user actually benefits.
Tie resource used tightly to the active lifecycle. Got it. Okay, let's try and wrap this up. If you had to summarize the absolute key takeaways from this dive into advanced lifecycle topics, what would they be?
All right, summarizing. I'd say number 1, understand the core state saving on save instance state is for small temporary UI state during config changes. For anything more complex or longer lived, use ViewModel for config changes, or room persistent storage for longer term. Number 2, embrace lifecycle aware components. Lifecycle owner, LiveData, lifecycle scope for coroutines. They automate a lot of the tricky boilerplate around starting and stopping observations or tasks based on the UI state. preventing common errors. Number 3, resource management is paramount. Know what to initialize, start, and on creation, start, and resume, but be absolutely rigorous about releasing resources, canceling tasks, and unregistering listeners in on pause and stop and destroy, especially on stop. This is where most leaks and background waste happen. And finally, number 4, use the right tool for background work. Foreground service for visible, ongoing tasks. Work Manager for reliable, deferrable background execution. Understanding these distinctions and how they interact or shouldn't directly interact with the activity lifecycle is key for complex apps. Mastering these areas really separates robust professional apps from flaky ones.
That's a great summary. It really hammers home that this isn't just academic knowledge. It directly impacts app quality. So here's a final thought for our listeners to chew on. We've talked a lot about managing state and tasks with ViewModels and lifecycle components. How might newer architectural approaches like MVI or UI toolkits like Jetpack Compose with its own state management system potentially change or simplify how we think about these fundamental lifecycle challenges? Does it solve everything or introduce new complexities? Something to ponder. Thanks for watching. For more such videos, subscribe to our YouTube channel for mobile app development content and join our WhatsApp community for mobile app developers. Links in description.